Now for our second inequality involving rational functions, let's apply our method, and our first step is to bring all of the non-zero terms to the left-hand side. So I'm subtracting 1 from both sides, and now I've switched to an inequality that's asking me to decide whether this left-hand side is less than 0 or not. And I can reshape this left-hand side using addition of rational functions. My common denominator is x plus 1, and the denominator here is 1 and 1, so x plus 1 divided by 1 is x plus 1, so this is x times x plus 1 over x plus 1. So I'm replacing the x by x times x plus 1 over x plus 1 minus 8 minus, I'm replacing the 1 by x plus 1 over x plus 1. And that's, I have to decide where that is less than 0. And now, again, I'm going to expand this x times x plus 1 and tidy up, and I get x squared plus x minus 8 minus x minus 1 over x plus 1. Now I have a rational function here. I have a quadratic over a linear factor, and that's a rational function. So gathering up terms here, this x cancels, and I get x squared minus 9 all over x plus 1 less than 0. And the next step is to factor that, and I get x squared plus 9 is x minus 3 by x plus 3. I'm dividing by x plus 1, and I have to figure out where that's less than 0. So I identify the factors. They're x minus 3, x plus 3, and x plus 1. And I figure out where those factors are equal to 0. This one equals 0 at x equals 3, x equals minus 3, and x equals minus 1. And now those 3 points divide the number line into 4 subintervals. Minus 3, minus 1, 3, and on those intervals the sign of this rational function remains the same. So I have to figure out the sign of this rational function using the signs of the factors on these subintervals. So let me identify the intervals. They're from minus infinity to minus 3 to minus 1 to 3, and 3 to infinity. And the next step is to figure out the sign of each factor. And remember, the sign of a factor can change only at the point where the factor is 0. So it has to be one of the points on our lists, or on our list, and then ultimately we're looking for the sign of this combination of these factors, which is our rational function. Now x minus 3 is going to be positive when x is bigger than 3, and negative when x is less than 3. So it's going to be negative on these 3 subintervals and positive on this one. X plus 3 is positive when x is bigger than negative 3, and it's going to be negative for x less than negative 3. And x plus 1 will be positive for x bigger than minus 1 and negative for x less than negative 1. So it's positive on 2 of the subintervals and negative on the other 2. And now this rational function is a combination of 3 factors using multiplication or division, and here we have an odd number of negatives, so it's negative on this subinterval from minus infinity to minus 3. We have an even number of negative factors here, so it's going to be positive on the subinterval from minus 3 to minus 1. We have an odd number of negative factors here, so it's going to be negative on the subinterval from minus 1 to 3. And everything's positive here, so it's going to be positive from 3 to infinity. We're looking for the points where this rational function is less than 0. The solution to this inequality is equivalent to the solution to our original inequality. And those points are for x between negative infinity and negative 3, and x between minus 1 and 3. So we can conclude here this quotient is less than 0 if minus infinity is less than x, which is less than negative 3, or if minus 1 is less than x, which is less than 3. What about the points minus 3, 3, and minus 1? Well, at minus 1, the value of the quotient doesn't exist. At minus 3, it's 0, and at plus 3, it's 0. And here we're looking for strict inequality, so we have everything that we need here. So another way to write the solution set of x minus 3, x plus 3 over x plus 1 less than 0 is equal to the union of these two intervals from minus infinity to minus 3, the union of that with the interval from minus 1 to 3. That's using set theoretic notation. Either notation is fine, it gets the point across that the solution set is anything for x less than minus 3 or x between minus 1 and 3.